a lot of questions have accumulated, and both to Richard and to Nuya. And I think we have about, good thing is we have more than 10 minutes to go through questions. So I think we'll be able to address quite a few. So maybe we start with Richard, or we can also mix things a little bit. One question was, how fast does the virus mutate in comparison to pathogens that mutate too fast to vaccinate against effectively, e.g. HIV?
Yeah, so so whether something is mutating fast or not doesn't have an immediate bearing on whether it is a vaccinatable disease or not. So measles mutates about as fast as most other RNA viruses, and there's a perfectly good vaccine. HIV and flu have a similar mutation rate, and vaccination doesn't really work. So for HIV, not at all. For flu, it's sort of a very transient endeavor. And that has more to do with how the virus and the immune system interacts and what sort of immune evasion mechanisms the virus has up its sleeve. So with flu, it's sort of a constantly changing glycan shield and sort of a whole bunch of decoy sites that can change quickly, but tend to be the immunodominant epitopes. So I'm not too concerned that vaccination here would not work. I think a vaccine has good potential to work, and certainly for an extended period of time. It could be that sort of 3-4 years down the road we see immune evasion, but for the time being, I don't think that's sort of a major concern. The mutation rate of these coronaviruses tends to be a little bit lower than most RNA viruses. So as I said, so about 2 mutations per month per genome, which is about a factor of 3 lower than some other RNA viruses.
So next question, and I should say, I don't see who asked the question, but whoever did, please send me an email because we're also working on this. So the question is, are you or others developing analytical tools integrating viral strain genomes with personal geolocalization data, for instance, from donated cell phone geolocalization history?
So the only information that we have on geolocalization is whatever was attached to the sample. I would think that the genetic resolution, so the genetic data gives you a very coarse relationship between different samples. That sort of I'm not quite sure how this would interact with sort of very precise geolocalization data. What we do have is some reports on travel history, which of course could be pulled from cell phone data, but there's no direct evidence or direct connection that we use as of today.
I mean, I guess maybe the question is pointing at the possibility that if you know exactly what virus strain you find in which person, then that tells you something about the transmission history. And this way we might learn more about transmission and how to work against transmission.
Yeah, well, it will certainly tell you, it gives you pretty good information about from where the virus got introduced in the population. So whether, for example, this Iceland example that I showed, there's a bunch of Icelandic genomes that nest within a US clade. And that is pretty strong evidence that, yes, there was probably some travel returnee from the US to Iceland that brought the virus with.
So next question, I guess you get this question a lot. People worry about these kind of issues naturally, I think everybody. And this question is, how many of the different genomes can be considered different strains? And have you looked into associations to disease severity?
There have been claims to this effect that there is 2 different groups and one is more severe than the others. As far as I can tell, these claims are complete bogus because they usually compare samples that have completely different statistical properties. So if you compare a sample from early in the outbreak, where most of the samples were from sort of severely ill people in Wuhan, you get and compare this to a sample made later in a different context, you will get a lot higher mortality in that early sample than in the later. but not because the virus is different, but the sampling strategies are different. So I don't think there's any evidence right now that mutations that we see have a functional effect. That doesn't mean that is not possible, but jumping to conclusions here is tempting, but not terribly well evidenced.
So maybe we give you a minute of a break and go to Nuria a little bit. So I think there were a number of comments to Nuria of people who want to contribute, both from inside Spain and outside, people asking for the link to your paper and people asking for the survey. So I think we can provide that subsequently on our collection of material. People are also asking about people are mentioning that the survey contains some countries but not others. So whether you're planning to include more countries.
Yes, definitely. And if anyone is willing to translate it, it's very simple. I send you Excel and you just translate the Excel to your language and automatically it is in that language. So we are doing everything we can, but there's a lot of countries in the world. So this is really a collaborative effort. I am speechless about the contributions of people. You know, there's this concept of citizen science and engaging with citizens to inspire them into contributing, you know, to make better science. And this response to the survey has been incredible. So I'd be more than happy to expand it to whatever languages you guys are interested in your countries. And yeah, and I will share the paper. Is almost done, but I've never written a paper so fast, I guess, in my life, like in one day, from nothing to having something. And also the methodology and all the analysis that we are doing and that we have done.
So next question, and I think that fits quite well with your general interests of doing machine learning with humans in the loop and interactions between machine learning and society. So this question is, how well are we able to predict the spread of the virus given so many dynamically changing parameters in terms of changing government regulations, changing mobility patterns, changes in medical capacity and so on? And how do we collect data in this scenario, considering that data collected on day 1 has presumably become redundant on day 20 of the outbreak?
Yeah, so that's a very good question. Every day we build 3 different models, which are meant to be like an upper bound, lower bound, and ideally the likely middle between them. And the models are, one of them is based on exponential growth. The other one is based on a SAIR model that was just explaining more detail. I didn't explain it because I anticipated that someone else was going to explain it in later presentations. And that SAIR model includes mobility, so you can adapt the rate of growth of infected depending on the mobility. And then we have a different model that is actually using a completely different approach. It's just a predictive model based on the time series of hospitalizations. Hospitalizations are a relatively good signal because everyone is in the hospital and they are get accounted for. And we know the rate of hospitalizations from infected. So we built a model using hospitalizations data to predict how many infected and how many hospitalized and there will be the next day. We also build models on intensive care and deaths. Having said this, the data is very noisy because the evidence depends on the protocol that is applied to gather that evidence. In most countries that I know of, they have changed the protocols multiple times throughout the crisis, and that has made a jump in the number of cases suddenly. Not because suddenly there are many more infected people. It's just because they are measuring them in a different way. They are testing more, they're testing less, they're focusing on testing this group versus this other group, you know, etc. So in the SAIR models that we build, the underlying model has a very high number of infected. And then we have another parameter that we infer, which is the detection rate. And this detection rate changes over time depending on the protocol that is being applied. So the model changes because the mobility might change, but not because of the detection rate changing. The number of infected is the number of infected. It's not changing because we decide to look at them or not. They exist. what we change is the parameter that is telling us from all the infected, how many are going to get accounted for. And this we also adapt every day, depending on what the protocols are. For example, another challenge is the availability of tests. So even if they don't change the protocol, there are many regions that run out of tests. So suddenly they don't have any cases, like the number of cases that's like really slow because they don't have any tests to confirm, so they don't count them as official, infected. So all these has to be taken into account in the model. Otherwise, the model doesn't explain reality. I mean, the model would totally fail. So it's it is a complicated process where there is an underlying mathematical model, but there is a lot of context, knowing the context, knowing what's going on, and tuning the parameters so they explain, reality. The most inspiring and empowering thing here for me and for all the people in the team, we are all volunteers. We are working, I don't know, really, really hard every day, Saturday, Sunday, every day. And definitely the most inspiring is to feel the impact of the work, because every day it gets shared with the president and every day it is used for making decisions. And this is, I think, an incredible opportunity to show how civilians can work hand in hand with public officials and decision makers to try to, make better decisions.
So you'll be happy to hear that we already have a few comments online of people volunteering to translate into other languages. I would like to try also. We have 2 minutes left. And since we have a number of people who are online in the Zoom conference, let's try some live questions also. So if I don't know if this is going to work, but as I mentioned, this is an experiment. So someone with a live questions to Richard or Nuria.
I actually have a question for Richard. Do you guys have any sense on immunization after you contract the disease? I know this is a somewhat debated topic, whether you would get immunized or not if you have gotten the coronavirus. Do you have? Do you know any can you share with us your views on that?
Yeah, so I fully agree. It's sort of an unsettled and somewhat controversial topic. There have been reports of reinfection. I don't really give too much on these because I think there are more reports even on sort of long-term viral shedding, and that PCR sort of comes up negative a few times and then positive again because there's some sort of viral RNA that's still being excreted. It's not so surprising. We do know that seroconversion does happen within 2 weeks or so. So people do mount an immune response and have IgM and IgG antibodies afterwards. What's probably most important for preventing infections would be IgAs. So yes, I do think there is going to be immunity, as with pretty much all other viruses of that type.
Okay. That's good
SARS
news.
too, we have seen sort of pretty good titers for at least a year. So I think these reports of reinfection are somewhat outliers.
All right. Oh, this is really great news. Otherwise, I think we're going to be really in bad shape once we reach this peak, because there will be another one if everyone is susceptible again.
And while sort of I might expect that reinfection could happen after a couple of years when the virus changes, I would also expect that reinfection is much less severe, more like the stuff that we see in children now.
Oh, cool.
So you have human coronaviruses that are just going around seasonally and cause cold, right? And it's quite how severe such an infection is depends a lot on your immunological predisposition. So I don't think it will be that bad going forward. Immunity is going to build up.